hello and welcome. This is section 3 of chapter 3, so 3.3, with slopes of lines. So we're going to be finding the slope of lines and talking about parallel, perpendicular, or neither. As we've already been working on, parallel is this symbol here. Perpendicular, if you forgot, is this symbol, means they intersect at a 90-degree angle or a right angle. And neither is just neither parallel nor perpendicular, which are just lines that cross each other at some weird or odd angle. And we're not going to talk about skew lines. They're a little bit different. So skew lines are never intersecting, just like parallel, but are in different planes. Parallel are in the same plane. So let's talk about some slope. So this is just some background knowledge that you should know. We have line 1, 2, 3, and 4. These are different lines, and they have different types of slopes. So a flat slope, one that is flat, is going to be a zero slope. A horizontal line, horizontal, are always going to have zero because it's neither rising nor falling. It's just staying constant or flat. Now, when I change this to a vertical line, so when it's vertical, the slope is actually undefined because when we're dividing by our x values, the change in x is actually 0. And we can't divide by 0, hence undefined. And I'll show you that in just a little bit with the formula. Then remember, a positive slope is going upwards from left to right. So this is positive. And a negative slope goes downwards from left to right. So that is a negative slope. So this is rising. So I'm going to say rises from left to right. And this one falls from left to right. By the way, reading graphs is just like reading English. You always read a graph from left to right. So that leads us into actually finding the slope, which, if you forgot, the slope of a line is the measure of how steep that line is. So it's the steepness, and it's calculated by the vertical change, or the rise, over the horizontal change, the run. So the rise over the run is what we're going to focus on. And we can use that with this specific formula of we're subtracting the y's, what's the change in y, and the change in x. So that is a key formula that you'll have to remember. And we also will write that as m, lowercase m, for slope. Just remember these x's and y's are the 2 points that are on the line. So we can calculate this slope in 2 different ways. So I'm going to show you the 2 different ways. We can either count, doing rise over run. So let's say the rise of this, and we're going to put it over the run of this. We're going to figure out that, and we're going to set it equal to something. So the rise, if I start from this point and I want to go to this point, how far did I go up the rise? So I'm going up 1, 2, 3, 4, 5, 6. So I went up plus 6. So my top is positive 6. My run is how far am I going left and right. So I'm over here and I'm going 1, 2, 3 for that. So my run is positive 3. Therefore, my slope, which we're going to use as lowercase m, is our slope, is 6 divided by 3, which is in fact 2. So 6 divided by 3 is 2, and they're positive, so just notice that they're positive, because if one of them is negative, then it has to be a negative slope. And a key giveaway, it's rising from left to right. By the way, if this one's going down, that's going to be a negative slope, so it could be double checking your answers. Now, we could have found this slope using the y2 minus y1 over the x2 minus x1 approach, which is very easy to do, and we're going to be doing that in a little bit, but why do it when you have a nice graph? So if you didn't know the y value, so let's go ahead and write down this point's value. So this is at negative 4 for my x, and my y value is also negative 4. So as you can see, the x value is negative 4, the y value is also negative 4. So x is over here, y is down, and then this one is at negative 1 and positive 2. So that one is at negative 1 and positive 2. Therefore, we can just subtract those. So it doesn't matter which one you pick. So if I want to start with this point, I'm going to take this minus that, and then this minus that, and put them over each other. So I have to do the red ones first. So let's do negative 4 minus 2 all over. Well, since we started with negative 4, we have to start with the blue one of negative 4 on this point and subtract a negative 1. And this gives us negative 6 over negative 3, which is in fact positive 2 as well. So that will get us the same answer, and they're both useful. So let's go ahead and do this next one, but I'm just going to do rise over run because why not? So in this case, I'm going from here to here. My rise is actually a fall. I'm going down 1, 2, and then 3. So it's going down 3. So my rise, if we call it a rise, is actually negative 3 over, and then my run in this case is over 1, 2, 3, 4, 5, 6, 7. So it's that. So my run is 7. So again, that's my run, and this is my rise. By the way, if you don't remember to put the negative in there, that's okay. If you remember that it's just going downwards, and throw on a negative in front of the two numbers. So if you just count 1, 2, 3 and 1, 2, 3, 4, 5, 6, 7, do 3 over 7, but we know it's going down, so we just plot a negative in front of it. That is okay. So I do want us to try to find the slope of just points without a graph, which is what we did on the other side. All I like to do is, hey, this is my first point, so it's x1, y1. And I'm putting them in different color codes, so highlighting them so that the x's go together when we subtract them, and then the y's go together when we subtract them. That makes it very easy to see, and it doesn't let us mix it up very much. So again, this is just a substitution problem. So the first one, what is y2? Well, y2 is right there, so I'm going to plug in negative 3. Because again, I'm doing y2. So I'm starting with the y2, which is negative 3. I'm going to subtract this y1. So we're subtracting, well, y1 is in fact 4. And then I'm going to go to x2, which is right here, which is 8. And I'm going to subtract this one, which is 3. And if we simplify that, we get negative 7 on the numerator on top, and then we get positive 5 on the bottom, which this is as simple as it gets, as negative 7 over 5 as our slope. Now, what we're going to do is find the slope of 3 different sets of points. So we have to find the slope here, and slope here, and identify if they're parallel, perpendicular, or neither. So let's just start with understanding what parallel will mean. So if you forgot, parallel lines, which we're going to use this vertical symbol like that, parallel lines have the same slopes. So they'll have the exact same slope, but a different intercept. So perpendicular is going to be this symbol, which will be the opposite, and what we're going to say, the reciprocal slopes. So they're going to be flipped, and the opposite of which is make it negative or make it positive. So those are the two things. So if you don't remember, those are parallel lines. That's perpendicular. Let me underline perpendicular. So those would be how we think about that. And neither is going to be neither of those. So let's find these slopes. So this slope of this one, we're going to make those. So again, if I do x1, y1, x2, y2, I'm going to start with my y's. So I'm going to start with the negative 8. I'm going to subtract the other y. And then since I started with negative 8, I have to start with the x's on the same point, which is negative 5, and minus the negative 1, which gives me that, and I can type that into my calculator to get negative 12 over negative 4, which is in fact a positive 3 for that slope. Now this next one, line 2, again I'm going to do the same thing, so I'll start with the y2 minus the y1 over the x2 minus the x1, which gives me 6 over 2, which is in fact positive 3 again. Now the last one, sorry if there's not that much room here. I'm sure that on your paper you have a little bit more room, or you can write it on the side if you need to. So then these last ones, this last line here, I start with negative 7, the y2 minus the y1, and the x2 x2 minus the x1, which will give me a, let's see, negative 7 plus 3, which is negative 4, all over 6 plus 6, because minus a negative is positive, which gives me a negative 1/3. And you can type that into your calculator to do that if you don't know how to simplify fractions. Now, these are my three slopes, and that's probably the hardest part. Now, which ones are the same? Well, slope line 1 and 2 are the same, so those are parallel. So line 1 and line 2 are, in fact, parallel because they are the same slope. So now if I look at 1 and 3, those are not the same. So they're not parallel, but they are, in fact, opposite reciprocal. So what opposite reciprocal means, if you forgot, is I take 3, which is 3 over 1, and I can flip it upside down to be 1 over 3, and then I'm going to make it the opposite, so it's negative 1/3. So the opposite reciprocal, we flip it upside down, and then I make it opposite. So if it was positive, it turns to negative. If it was negative, it turns to positive. Those are opposite reciprocal. So these are, in fact, perpendicular to each other. Another way to do that is if I do 3 times negative 1/3, if that equals negative 1, that also is another way to do it. So 3 times negative 1/3 is negative 1, therefore it is perpendicular. And we also notice that those are the same things, 3 and negative 1/3, so that's also going to be perpendicular for lines 2 and 3. So what I would like you to do is try one of these. I know that these are a little bit difficult, but please try it. I will have an answer for this after you pause it and try it on your own. So you should have got negative 2, and 2 for those slopes. Notice how those are the same, so 1 and 2 again are parallel. These ones are all different, so they're not, so 2 and 3 and 1 and 3 are different, so they can't be parallel. So it's not those. Are they perpendicular is the next question. And again, just multiply the two. So 2 times negative 2. 2 times negative 2 is not negative 1. It's actually negative 4, hence not negative 1. Therefore, it's neither. Again, if we multiply those two and those two, they should be negative 1 in order for it to be perpendicular. Or the opposite reciprocal, which would be, in fact, positive 1/2, not positive 2.